But somehow, when a human being interacts with a machine, the expectation of a certain amount of definitiveness tends to go up dramatically. You somehow
Yeah.
feel that when the machine is telling you something, it is absolutely telling you the truth.
One of the first use cases of AI that I encountered, as in the new wave of AI, and this is again pre-COVID, where Google had said that depending on the kind of incoming searches, they can predict whether a flu outbreak is going to happen in a certain part of the US.
So, what happens in AI? If you approach this systematically and scientifically, 1 year or 2 years later, suddenly the performance of the system starts dramatically improving. It's able to better identify, it's able to correct the errors it did. A child may read a paragraph in Gujarati, Hindi, English,
Yeah.
and the AI will tell you exactly how well you read it, how many words you missed, what are your pauses.
Hello, and welcome to another episode of Our Own Devices. This time, we're going to talk about how a technology like AI can help bridge the kind of gaps that we have in a country like India, especially when it comes to governance and administration. We have with us Mr. Shekar Sivasubramanian, who is the head of Vadhvani AI. Sir, welcome to the show.
Thank you. Thank you very much. Thank you for inviting me.
So people who have been, working on tech or, have like somebody like me who's covered tech for 2 decades, we know about Wadhwani AI, but for the benefit of our listeners, if you could just give a little bit of context on what, Wadhwani AI works on, and then we will get into a little bit more detail of how we are trying to help the government fix a lot of these problems.
Sure. Vadhvani Institute for Artificial Intelligence is the name of the
Yeah.
organization as we approach the world with our work. The institute was set up in 2018, inaugurated by the Honorable Prime Minister. The first about 2 to 3 years, the institute was focused a little more on research within the AI space. Then we made a significant change in terms of direction, and we started working in what we call applied AI. So
Yeah.
in a way, you can see there are two large aspects, and then there's a third aspect in the middle. So the academic, the tech companies, they do a lot of the work either on research or invest in enormous amount of funds in the more recent past, ever since the LLM world came in or generative AI came in, into solving problems using a variety of techniques.
Yeah.
As most of us know, AI has been in place for a long time. It's been there for about 30, 40 years in a different way.
Yeah.
Knowledge eliciting, creation of knowledge bases. And then there's the marketplace, which is always aspirational. There's a lot of uncertainty, whether it's in the social space or even it's the commercial space. And then there's the middle, which tends to be a little bit of a vacuum because you need to be able to translate real life problems, which are often within a certain amount of ambiguity and uncertainty, and then use the technology which is already available through tech and research, define the problem, solve it, integrate it into an ecosystem in technology, in a pipeline, etc.
Yeah.
Meet the program changes required in order to make it happen. Make sure you address the final end user challenges in terms of usage of the applications, which in India in the social context means typically multilingual, multicultural, and in particular, if you're addressing the rural spaces, simple interfaces that are intuitive and much easier to follow,
Yeah.
and then work through that so that the entire benefit of the technology finally accrues to the individuals using it. So that's our
True.
journey. Every project or every problem that we work in where AI happens to be used goes through the standard journey of problem identification, solution, working with the government, working with the states, making sure it's integrated, making sure it works properly, and then working to get the benefits for the end user. And we've got
Yeah.
about 25 solutions in the space of education, health, and agriculture. So that's the
Okay.
work that.
Yeah. So, if you look at a country like India, obviously there's so many people, and it's not possible even for a massive missionary like the Indian government to cater to all of them. So do you think, AI has the potential to at least cater to the first touch point of all kinds of users? Again, as you said, it bridges the gap of language, it bridges the gap of cultural differences in a country like India. You know, it can cater to a person in their context, wherever they are, maybe in rural India, in South India, East India. So is there a vision that at least the first touch point can be handled by AI, and then it takes on from there, so that a lot of the frustration that a regular person has in India, that he has to wait in long queues to even meet somebody, and then be told that maybe you've come to the wrong counter.
Yes, yes, with a caveat. And
Okay.
the caveat is that most of the thought process of being the first touch point tends to use LLMs. It is really
Yeah.
centric on an interface that is citizen facing or individual facing that solves specific problems. That is one aspect of AI.
Yeah.
So, assuming that um, you have that particular problem set where there is a individual who is looking for a specific type of assistance or a specific type of resolution or information, then such solutions indeed can be delivered. Even there is a second caveat. Because
Yeah.
of the very nature of human interaction and the expectation of the manner in which people want to use such technologies, trust is very important. Even though when humans interact with humans, it is not necessary that every interaction is trustworthy. But somehow, when a human being interacts with a machine, the expectation of a certain amount of definitiveness tends to go up dramatically. You somehow
Yeah.
feel that when the machine is telling you something, it is absolutely telling you the truth. Whereas with AI, you've got the challenge of, with the most advanced of AIs, you've got a residual error rate. There may be one in 1,000, one in 10,000, one in 100,000, where the answer may not be quite as correct. And those
Yeah.
technologies are evolving. Now, when the problems are what I would call benign, easy, they
Mm.
offer a first level of support where the negative outcome of AI is not catastrophic or not negative or
Yeah.
not having liabilities which cause a problem for the individual. It's relatively easy to adopt it. Now,
Yes.
what is important is because the training of AI is largely done not necessarily on the types of situations that we require to solve for the end users who may need this answer. Therefore, you've got this hurdle. You've got the hurdle of making sure you get a level of contextual data using which, if you train models, then the answers tend to be very good. Having said that, indeed, it is very correct for us to have an aspiration level, but for several things. So, if we were to categorize the types of questions people ask and say 70 to 80% of the questions are fairly straightforward and mundane, that can be dispensed with fully with AI. You need not worry.
Yeah.
So a good AI design will say, if I'm confident that my answer is correct, I will evaluate myself and then deliver the answer. If I'm uncertain, I'll go to a human expert. So it reduces the load on the human system, which is of tremendous value in India.
Yeah.
It improves the efficiency, the efficacy, the resource allocation at an aggregate level. Wherever you look at it, if you look at a railway reservation or a large scale situation where large number of humans come,
Yeah.
tremendously valuable. So your point is correct. However, we need to address all these things in order for it to be trustworthy and effective.
So you also mentioned the three areas where you know uh, um, in which you guys are working, and you also mentioned uh, the fact that you have to be careful about how that first touch point doesn't end up with a liability, right? But when you look at the two, you have medicine or uh, um, in case of a lot of diagnosis, for instance, which can be done, screening that can be done effectively with AI. But there is, of course, the risk of getting something wrong, even though it might be a small fraction. So how do you balance that? Because I understand that um, you know, a lot of the work that is happening, especially in a country like India, is in ensuring that the first level of screening, for diseases and all. And I remember from a few years back, one of the first success stories I'd heard uh, about AI was in the case of cataract screening. That it could do a very good job there, and then escalate the cases that needed to go to maybe a doctor or a specialist.
Yes. So I think the term you used is important, screening.
Screening, yeah.
When you do screening, the question that you must ask is when you solve a problem using AI, what is the contemporary practice? What is the current level of practice? And
Yeah.
what is the current level of performance that it is delivering?
Yeah.
If you can augment the performance of an existing system, let me use a small example. If you're doing something like vulnerability mapping of districts for TB,
Mm.
the traditional method of doing it, I'm just using a hypothetical example.
Yeah.
We do work in this space and we're in the process of rolling this out across the country. But if the current number of cases that can be found using traditional methods to identify the most vulnerable places is one number, and if AI can augment that number, you're in a good space.
Yeah.
Likewise, now what is very important specifically on individual cases, in other words, when you're doing a specific interpretation using AI on an individual case, screening is not a bad thing. What you have to be very careful is when you come to a conclusive fact that this person has XYZ problem and needs medication. That should not be done without a human in the loop.
Look.
Finally, what AI can aspire to do, at least in the foreseeable future, is to reduce the workload so that you can make the most appropriate cases within patients, the ones who need the most attention. So, for instance, we have a AI solution in TB. When a TB patient comes in for treatment, they are given a treatment regimen, and because of the social constructs in India, sometimes patients don't follow their treatment regimen properly.
Yeah. Yeah.
And if they don't follow it, we call it loss to follow-up. It creates a lot of additional problems because the cost of treatment goes up. They start getting multi-drug resistant TB and they spread the disease.
Yeah.
So when patients come in, two ways. The health system can say, look, all the patients coming in, will follow up with them. If AI is used, AI can rank with a score of 0 to 100 for the patient, saying a higher score means this person will probably not follow medication properly. A lower score means this person is okay, you need not follow up with this person.
Okay. Okay.
So what have you done with that? You have ensured that in a resource-constrained environment, which tends to be all settings, business as well as government, everywhere, you are in a resource-optimized setting. You would prefer to go after those people where the probability of their not following medicine is higher.
Is high.
You get that assistance. After some time, you start seeing impact in the system, which we are able to see now. We have rolled it out across 12 states. We are able to see that difference. We're able to see that the number of patients who are getting into problem is slowly and systematically reducing. So what has AI done? It has intervened in a manner which has augmented the performance of the health system without sacrificing or causing any problems to take place. So this technique of placing AI, I'll give you another example, just to give you a completely different example. We look at about 70 to 100,000 articles available across 12 to 14 languages in the internet, published sources of reasonably authorized information. So these are news sources, etc. So we look at that, automate it, and we identify from news articles after sieving out all the matters of not of importance or relevance for us. We look at health events. We look at events where we are saying in a place P, some place, some disease, there are certain number of people who were impacted and they either got it for the first time or there was a fatality. This may get reported across India. In an automated manner, if you pick that up, and then you use AI. There's a lot of AI because you've got to extract that information. You have to
Yeah.
get the
Yeah.
exact information. You
Yeah.
take this, it's called an event of interest. You publish
Mhm.
it using an appropriate interface to an individual who gets a set of events. Then they determine, hey, this one's an outbreak.
Yeah.
And they immediately, and all the software is integrated and provided for the person. So when they
Yeah.
click on a button, immediately it goes down to the state and the district to take
Yeah.
action immediately.
Okay.
This latency for solving this problem is 2 to 4 hours.
Yeah.
Earlier, what would happen is somebody would look at a newspaper, type in the information, send it on email. It goes to a central location. They will review the email and then make a decision. Could be 3, 4 days.
Yeah.
Again, AI is used in a manner here where it augments the performance of the system. It
Yeah.
drives an efficiency in the system. These are, your classic, and just as a anecdotal aside, we ran
Yeah.
the same piece of software, except what we did was we tried to locate children who could be awarded Bal Puraskar because the entire processing was the same. All we needed to do was
Okay.
change the
Got it. Yeah.
semantic. And this past
Yes.
year, 2026, 2025, we found 2 children. 2026, we found 4 children. We gave the government department a list of 5,000 possible candidates, and they
Yes. Yes,
identified
sir.
4 who otherwise would not have been found.
Yeah. Yeah.
And
Sure.
this happened at literally, 5 days of a national
Yeah.
run.
Running a. Yeah.
You get it.
Yeah. Yeah.
Again, these are examples, and we have also released the same thing in agriculture, where we tell the department all the problems. So these are examples of way AI can and should be used
Yeah.
to socialize the usage of AI with minimum disruption and maximum positive impact. It comes to the design of AI.
Yeah.
It's the way you have to
So.
design.
So. Uh, I'm reminded of one of the first use cases of AI that I encountered, as in the new wave of AI, and this is again pre-COVID, where Google had said that depending on the kind of incoming searches, they can predict whether a flu outbreak is going to happen in a certain part of the US, because people are searching certain symptoms, or people are searching the price of paracetamol, and so if you collate all these kind of things, so this ability of AI to see these patterns. And as you said, pick out that needle from the haystack, right? Which a human will struggle, right?
That is correct. And they are
Yeah.
very effective and appropriate uses of AI.
Yeah.
The vulnerability mapping that we did, also
Yeah.
very interesting. It's a complicated problem. But
Yeah.
what you do is you break the country into 500-meter by 500-meter tiles,
Yeah.
square shaped
Yes.
tiles.
Yeah. Yeah. Yeah.
And you try to ascribe socioeconomic and demographic parameters into that space, which is look at it as being representative of a set of possible factors that can affect how health outcomes in that space.
Yeah. Yeah.
If you're I will contrast 2 things. If you're staying in a very low populated, very neat and clean environment with very little things going on, then
Yeah.
there is a health outcome X. If
Yeah.
you're staying in a place where there may be residual water, maybe sanitation is not very good, maybe water pollution quality may be high, maybe there are a lot of vegetation growth that is very arbitrary, that
Yeah.
signals something about that space. So if
Yes.
humanity is living in both these spaces, just like your Google example,
Yeah.
except it is not a search, but it is real
Yeah.
life,
Yeah.
it is signaling something. It is
Yeah.
actually emitting some information about itself.
Yeah.
If you can capture that information that is getting transmitted every day, actually, and then you can codify it with intelligence, and you can use that to understand and predict certain outcomes, which we believe may be correlated to those underlying factors, then you are doing something interesting. You are taking generally available, publicly available data at a very low cost and using that to come out with insights. Once more, you are not coming out with a precise insight, not even needed. You are
Yeah.
just going to say A, B, and C. These areas are high requirement of attention.
Yeah.
And as and when the system starts working on this, they will either say that, look, you did it wrong, AI, or you did it right, AI, which becomes
Yeah.
further labeling for us. So what happens in AI? If you approach this systematically and scientifically, 1 year or 2 years later, suddenly the performance of the system starts dramatically improving. It's able to better identify, it's able to correct the errors it did, it is able to get rid of the features that were not important. So it improves itself. So these are all examples in which a lot of things that happen actually are taking place in general. And depending on the nature of the problem, now, if you've got a very specific problem, like you are doing an eye scan for determining diabetic retinopathy, it's a very confined problem. It's a very precise problem. You need an equipment, you need a photograph, you need a precise interpretation, and you can come out with it. That also we have. So we've got solutions that span. In health, we are discussing these kinds of things. I'll give you an example in education. We have a solution where a child may read a paragraph in Gujarati, Hindi, English,
Yeah.
and the AI will tell you exactly how well you read it, how many words you missed, what are your pauses. We've integrated this into the health system in one of the states, into their, not health system, sorry, the education system in one of the states. And it's part of their assessment process.
Okay.
Now look at this, how much of an advantage it is for teachers. You have this is part of their normal assessment. But now with AI, you can literally we do about 5 and 6 lakh such
Studies
assessments.
now. Yeah.
Yes, and then you're able to identify many other insights. You can map the state and say, these districts don't seem to be performing well. You can say, these types of cohorts of children seem to be having some difficulty. So each of these are, again, I will make the statement, it's extremely important to design the AI correctly.
Yeah.
AI, inside technique of AI, which is where people place most of their focus on, is the smallest problem.
Yeah.
The placement of the solution in the ecosystem, which means you've understood what you're solving for, is a much more important aspect of AI. And that is important.
Yeah. So this design that you're saying, right? It's also, how important is it for us to sort of evaluate, because this is an emerging technology, and it's very potent. It's opening up a lot of things that we were uh, earlier not using technology for. So how important is it to evaluate the kind of areas that, okay, it can, like, I heard a few examples from Vadhvani AI where, like, it's all new things, we haven't been doing this before. So how important is that design, that, okay, there is a specific problem that we can tackle, or or in some cases, maybe we are not even aware that this is a problem that can be tackled.
It's extremely important to, when you go into a problem and you start understanding it, it is super important to understand the problem first, thoroughly.
Yeah. Yes.
That's, AI discussion should not even come. There is nothing.
Mm.
First, understand the problem thoroughly.
Yeah.
I often discuss when I'm speaking about this, a simple problem where AI can help. It's a one-line problem, which is, will this street dog bite me?
Okay.
It is a problem.
Yeah.
It is a problem in society.
Yeah.
It is an interesting problem to solve. Now, the moment you have a problem like this, immediately we can discuss, is it a dangerous problem? Is it something that will cause a harm to anybody? How should we design this? How should we think about this? Who are the users? What will they use? How best can they actually come to a resolution of the problem that we feel we are solving for? Are there any negative risks of this? Does this cause any side effects? All of this, is it responsible? Will there be biases in the system? Now, in this dog problem, all that is not there. But in many things, these kinds of questions have to be asked literally on day one.
Yeah.
This is not to be, a lot of the challenges take place because people get excited with the tool that they have and not the problem that they have.
Yeah.
So because I have a hammer, everything is a nail, I go banging here and there. It's not the way to solve problems.
Yeah.
Many times, even in that loss to follow-up problem,
Yeah.
We pitted our algorithm against the two rule-based systems that we came out with, saying if we have a rule-based system, classic software rule-based system, can we beat it substantially? That's an evaluation. That is telling, can a rule-based system do the job? Because if a rule-based system can do the job, then don't waste your time doing AI.
Yeah.
You have to have both engineering and scientific approaches, as well as domain-centric approaches that do the in-depth analysis. And because we are a not-for-profit, although we are a very, very much more aggressive organization because we want to get the results for the benefit
Yeah.
of.
Out. Yeah.
But because we're a not-for-profit, our stance is, we don't have to worry about the profitability related matters that other organizations may need to be concerned about. We can spend more time to solve the problem for the reason we went in the first place, which is to actually solve the problem. So
Yeah.
we did not get distracted either by the coolness of the solution. Those things not very important.
Yeah. Yeah.
Are you solving?
Yeah. So it's a very interesting conversation, and we can go on for an hour or so. But in the interest of time, I'll ask you a last question. Um, which is that you are solving a lot of problems here, and I've often heard in the sense of technology, for instance, that if you solve it for India, you solve it for the world. Because it's going to have a very effective implementation, at least in some parts of the world, like Latin America or Southeast Asia. Uh, and the other thing is, do you think there are problems that have been solved other parts of the world, which you think can be brought into India, or do we need to solve these problems very uniquely in our context, in our cultural setting? And do you think when we solve such problems, using technology, especially AI, do you think that can easily be taken to other places so that humanity itself benefits?
Um, I have been biased in favor of trying to solve problems in India. We are
Yeah.
open to techniques associated in artificial intelligence, which advances the problem-solving technique.
Yeah.
However, my personal observation and belief is that because we focus on the problem, the problem is unique to a place where it resides.
Yes.
You cannot separate the problem from its context.
Yeah.
Therefore, and if our approach is that problem is important, solution comes after.
Yeah.
If we accept that to be the approach of problem solving, you have to also accept the fact that it has to be done locally. You can depend on, you can get a better scalpel, you can get a better hammer, you can get a better car, you can get a better tool set. All that is a matter of detail. But the problem is resident in one place. Now, if you solve the problem in India, because of the diversity of language, culture, complexity, the human ethos, if you were to draw a Venn diagram between the behavioral and cultural and socio-demographic aspects of India with other parts of the world, all of India with other parts of the world, there may be a greater overlap. Therefore, you can come with the construct that if you've solved it for India, probably you've seen a lot of the problems that you will see in other parts of the world. Having said that, I will say if we solve it for any country, you have to finally contextualize it very strongly for that country because
Yeah.
behavior patterns, food patterns, socio-demographic patterns cannot just be simplistically taken from one place to another. The reason is it will manifest itself in a failure later on in AI because that assumption is wrong. It's far more cautious to say, let me validate it. So if I have a set of parameters that I have built my model on, a set of assumptions, let me make sure that those are indeed similar in the new geography before I go in. The advantage with India is the number of assumptions and the complexity is so large that it's very likely that you've probably seen a lot of problems around the world here.
Yeah.
In terms of design challenges, complexity, usage, speed, culture, language. So you're confident that the complexity is much higher. So
Yeah.
you know that you've pretty much seen it all. That doesn't
Yeah.
mean that you can be excessively overconfident saying, I'll just go in any other place. You still have
Yeah.
to maintain that disciplined approach when you solve the problem in any new place. You have to see it for what it is.
Sir, thanks for your time today. It was wonderful listening to you. And again, as I said, there's a lot more we could have covered, but again, in the interest of time, we have to wind up now.
Most certainly. Thank you. Thank you very much again. Thank you for inviting our institute for this program. Thank you very much.
So we'll be back again next week with another guest and a lot more knowledge and insight. Till then, we are available everywhere you listen to your pods.